Okay, so we've got an integral here. We're going to integrate from e to e squared, the square root of x squared plus 1 over x with regards to x. Now this is quite an interesting looking integral here with a radical in the numerator. If there's a radical in the denominator, there's maybe some sort of trig identity maybe we could use. But here we're stuck with the radical in the numerator. So there's more than one way about getting the answer to this, but you can u sub many different things here. What I'm going to do is u sub the whole of the numerator. So u equals square root of x squared plus 1. Then usual business when you're doing u substitution, I'm going to take the derivative of this. Well, the derivative of a radical always start off with 1/2 and then put the radical in the denominator and then multiply by the derivative of that radical. So x squared plus 1, derivative of x squared plus 1 is 2x. Okay, so now we need to just simplify this off a little bit. The 2's will cancel out and we'll get du equals x over square root of x squared plus 1, and that's our dx. Okay, now our result here for our du, we've got square root of x squared plus 1. Now we've got square root of x squared plus 1 here in terms of u. So why don't we put that one in there straight away? So now we've got du equals x over u dx. Now, if we get dx on its own, we're going to get u over x. So we'll have to take the reciprocal of that. But maybe we could get the x out of this and make this all in terms of our x straight away. So if we let u equal square root of x squared plus 1, to get x on its own, we'll have u squared equals x squared plus 1, and then we'll have x squared equals u squared minus 1, in which case square root of u squared minus 1, that will equal x. So then we could put that in there in our numerator. So let's do that. So now du equals square root of u squared minus 1 over u dx. So when we substitute in for our dx, we'll just take the reciprocal of that and just plug that into our integrand. So let's go with that. So now my parameters of integration, I'm going to leave them as they are and not try and find them in terms of u, because when I've finished I'm going to go back in terms of our x. So I'm going to leave them out for the rest of this integral. I hope you don't mind that. And then we'll go back to these parameters rather than keep trying to change things over, because that could get quite complicated with this stuff going on in here. Okay, so square root of x squared plus 1, that'll give me u. And then my x is the square root of u squared minus 1. And then my dx is just a reciprocal of this term here. So I multiply that by u over square root of u squared minus 1 du. Okay, well, let's just simplify this off, and then we'll get u squared divided by u squared minus 1. So multiplying these together, and then that's du. Okay, now this is just a little bit awkward to integrate from there. So I could do a nice little trick here. If I put u squared minus 1 to make that into 1, but obviously I've changed the value of my integral. So if I then go on and add 1, I'll then not change the value of my integral, and then I could split my fractions. So now I've got u squared minus 1 over u squared minus 1. So that takes care of this part of my numerator. And now just do 1 over u squared minus 1. And then this is all du. So then that is still the same as what I've got here. And it's the same as this. These will cancel out and give me 1. So now I've got a nice integral here. I've got the integral of 1 plus 1 over u squared minus 1. Okay, now that's a really straightforward integral, no problem. This one here, well, there's a bit of work I need to do on that, but u squared minus 1 I know that that could be u minus 1, u plus 1. So that's going to lead to partial fraction decomposition. So let's do my little setup on this side, and here I'm going to write my integral in terms of my partial fraction decomposition, my building blocks of that. So 1 plus 1 over u minus 1, u plus 1. So that's the integral I'm trying to partial fraction decomposition in terms of this part of it, and let's take this off the board and do that over here. Okay, so let's take care of this over here. So 1 over u minus 1, u plus 1. So partial fraction decomposition, set up the building blocks. I will have a over u minus 1 and some value for b divided by u plus 1. So that's my building blocks. So now what I want to do is to try and get some sort of values for a and b. What I can do is multiply both sides by u minus 1, u plus 1. So let's try that. So then what we'll do is on this side I'd have u minus 1, u plus 1 divided by u minus 1, u plus 1. So that's what happens when I divide this by it. And then the same on this side. I'll have a times u minus 1, u plus 1 plus b u minus 1, u plus 1. And then still bring down this fraction here, u minus 1, and this one will be u plus 1. Okay, now we can simplify this off quite a lot. So these two terms will just cancel out and just give me with 1. And then these ones here will cancel out, and this one here will cancel out with this one. So now we've got a nice equation here where we could solve for a and b. We've got a times u plus 1 with these cancelled out, and then we've got plus b times u minus 1. Okay, well now we can just trial in some values for u, two different values to get the a and the b. So if I want this one to disappear, I'll let my u equal minus 1. So let's do that. So u equals minus 1. This will disappear. So I've got 1 equals b minus 1, so that's minus 2. So I've got minus 2b equals 1. So therefore b equals minus a half. And then for this one to disappear, let's let u equal plus 1. So now u equals plus 1. I will then have 1 equals a will stay, and 1 plus 1 will give you 2, so that's 2a. This will disappear, so a equals positive 1/2. Okay, so therefore then I will have this a will then be a half, and my b will be minus a half. So then 1 over u minus 1, u plus 1, that equals a is 1/2, so I've got 1 over 2 times u minus 1 plus, well it's now minus, so I can put minus in there, and then I've got 1 over 2 times u plus 1. So that is the same term. Okay, so I can rewrite my integral in terms of this partial fraction decomposition. So let's do that and bring this up to the top up here. Okay, so we've got our integral here now looking in some sort of form where it looks pretty reasonably straightforward to integrate. So let's go straight into that step. So integrating all this with regards to u, we will get, well 1 will just give me u, that's fine. This one here will give me natural logarithm of u minus 1 multiplied by a half. So I'm going to write that as natural log absolute value u minus 1 over 2. And then this one, I've got minus a half of natural log of u plus 1. So minus natural log of u plus 1 over 2. Okay, now, and as I promised at the start of the video, I didn't use my parameters of integration when I went into the substitution, because I'm going to go back into the x world, which we can now go into now we've done our integration. So let's do that. So every time we see a u, we just write in square root of x squared plus 1. So now our integral is the square root of x squared plus 1 That's this term. Now this one. So now we add the natural log, absolute value, square root of x squared plus 1. So that's just this bit. But we still need this minus 1 inside the absolute value. And that's all divided by 2. And then this one, similar process, but with a plus 1 rather than the minus 1. Okay, so minus natural log, absolute value, square root of x squared plus 1, and then add 1. And then that's all over 2. And then we calculate this to our parameters of integration, which is e and e squared. Okay. Now, in the previous time we did this integral, we didn't go through this step here because there's a nice trig identity here using logarithms and the arcsinh function. Now, I want to thank Jan Willem Reens, who messaged in to say that the steps here looked a little bit confusing. So what I've done here now, I'm going to go straight into the trig identity, and then I'm going to make a separate video which will be in the link below showing you how we got to that. So now what we've got is this, all of this here is a log trigonometric identity which gives us the arcsinh function. So this is the sinh of, well, the inverse sinh function or arcsinh function of 1 over absolute value of x, and it's the negative version. So all of this here will give us this. And then what we can do is we still evaluate from e to e squared. And this term here just comes down. So now we've got square root of x squared plus 1. And now we've got a minus inverse sinh of 1 over absolute value of x. Okay, now I'm going to show a graph at the end of this video comparing this function here with this function here, and then you can have a look and see what happens with that function. Okay, so now back to the integration. So this is still calculated over these parameters. So e to e squared. Okay, right. Let's plug in e squared first for my result. So wherever I see an x, I plug in e squared. So let's go with this one first. So a nice big bracket for my e squared. So now I've got the square root of e to the 4. So e squared squared basically, plus 1, minus arcsinh function. Now here we've got 1 over the absolute value of x, because that's what we had in our algebra there. But here we've got e squared, which we know is positive, so we don't need the absolute value function anymore. So 1 over e squared. And then that's all bracketed, and now we subtract that with the values at e. So in this radical here, we now have e squared plus 1 minus the arcsinh function of 1 over my e. So let's put that in there. Okay, right. Let's just simplify this off a little bit. So the square root of this one, that will stay. E to the 4 plus 1. Let's get the square roots together. So this one is going to be a minus. So that's minus the square root of e squared plus 1. Now, we've got a minus here, but this one is minus minus. So I'm going to write this one first. So that's a plus. So sinh. And then here I've got 1 over e. So I could just write that, instead of a fraction in there, I could just write e to the minus 1. And here I'm going to subtract this one. And as I did for the same format of the previous sinh, I'm going to write that as e to the minus 2. Okay, now if you plug this into your calculator, you'll get an approximate value, 4.785. That's what your answer to that will be. And if you stay on, I'm going to put a graph of the integral and also its original function, and you can have a look at those graphs as well. Okay.